Two things today. LOS stands for Law of Sines. LOC stands for Law of Cosines. You guys are great at pattern recognition. This is huge. The reason this is huge is because everything we've done up until this point has always had the restriction of one simple thing. You gotta have a right triangle. It's right triangle trig. Okay. Pythagorean theorem, right triangle. 45, 45, 90, right triangle. 30, 60, 90, right triangle. SOHCAHTOA, sine, cosine, tangent, right triangle. This revolutionizes all kinds of fun things. Once you learn this, some of you are just going to forget about right triangle trig and use this all the time. You don't want to do that. This is not easy stuff. Right triangle trig is really simple compared to some of these calculations. Okay, but this will allow us to calculate lengths and angles in any triangle, regardless whether it's right, acute, or obtuse. Okay, so let's start with that guy. We got a triangle. Will, is that a right triangle?
No.
How do you know?
Because it's actually,
What'd you call me?
or it actually.
That's Mr. Ashley to you. No, that's Ashley. I'm Mr. Reedy. See that blue thing next to you? That blue thing right there?
Yeah.
Yeah. Mm-hmm.
Actually, it might be a right try. It
Reedy, Ashley.
It may.
Stop calling me Ashley.
It may be a right triangle.
Well, there's no may. This is math. There's no may. This isn't social studies where we talk about, well, maybe he did that, maybe he did that.
I don't think so, but I don't know why.
Morgan.
It's not a right triangle, so when you add 33 and 47, you get 80, and when you subtract that from 180, the other equals.
Bingo. First thing we know is that's a 100-degree angle. We're not going to use that information. I want to find x. And so on the next slide, we're going to get something called the law of sines. But I think it's important that you see where the law of sines comes from. Okay, so this is what we call a derivation. Okay, how we get the law of sines. If I want to solve for x, we can do it with the information we have. It just requires that I insert one extra segment right there, also known as an altitude. How would I use that altitude to find x?
You could like find the measurement of the two angles in the top.
I could find the what?
The measurements of the angle in the top.
This angle?
Yeah.
And this angle?
Yep.
How?
Subtract 90 by 33 and 47.
Okay, so that would make this 57, and this would be
33.
how much?
43.
That's what I thought you said, 43. Okay, good.
Then you could use one of those sine. Oh wait.
One of those, which one?
Let's use sine.
Sine of
Maybe 33.
equals.
The variable.
Let's call this, let's call it y.
Okay.
Okay, y.
Y over 14.
Good.
Then you could get another equation. And
Let me write that down. We would do the sine of 33 is equal to y over 14. That would tell us what y is. Okay, so now we know y is, some number.
Yeah.
Hashtag.
Then you could use that to find the measurement of x. Sine of 47 equals the value of y over x.
Beautiful, let's give it up. Was that an easy process? No, it was icky. So let's use the law of sines instead. Here's the law of sines. There's 3 parts there. You're only going to use 2 of the 3 parts depending on the problem you're solving. So the law of sines says if you take the sine of an angle and you put it over the measurement of the side opposite that angle, sine of A over little a, that's going to equal the sine of a different angle over its opposite side. So you pick and choose what you want to use. You know A and you know B, then you use the first 2. You know A and you know C, you use the first and the third. You know B and C, you use the last 2. You're not going to use them all at the same time. You can't solve an equation with two equal signs. Okay, ready for some fun? Let's go back to the same example and solve that using the law of sines. So I know angle C, I know angle B. Do I know a measurement opposite one of those angles?
Yeah.
Yes, I know 14. Therefore, I can set up the law of sines. So go ahead and set it up before I click and you see what I did. Click and see what you should do. So we're just focusing on setting it up now. We'll solve it in a second. Unless you're an overachiever and you want to start solving right away. If you're not saucy, go ahead and solve it. Okay, so there's the setup. Everybody good? Okay, how do I solve that? Cross multiply. Thank you. I skipped a lot there. I cross multiplied, I got x up times the sine of 47 equals 14 times the sine of 33. Then I divided by the sine of 47. Plug that monster into my calculator. Lo and behold,
10.43.
10.43. That's an approximate answer. Store it just in case you need it later. Hopefully you see that that's easier than the previous method we talked about. How would I go about finding the length of CB now? You did the math. How big is angle A? 100 degrees. So notice, once we have the relationship of an angle and the side opposite it, we can use that for all kinds of law of sines. So I use this and this to solve for x. But if I was looking for CB, I know that that angle's 100 degrees, so I could do the sine of 47 over 14 is equal to the sine of 100 over CB. Cross multiply, solve. When you're done, apply the small, medium, large theorem to make sure you did it correctly. Smallest side should be opposite smallest angle, medium side opposite medium angle, and longest side is opposite largest. I don't think that's what he was looking for. Yes, sir?
No, can this work in a right triangle?
Sure.
Okay.
Yeah. It's just too much work when you can just set up sine of x is equal to blah, blah, blah. But there's nothing wrong with it. You'll get the sine of 90 over something. What's the sine of 90, by the way? That's like a little up there. 1. Right, so that'll work. Okay, easy? Law of sines is a lot easier than law of cosines. Go ahead, find the measures of A and B. This one's a little trickier. Anytime you're looking for an angle measure, at some point in the problem, you're going to have to end up using the inverse sign. The trick is figuring out where and when. I guess the first question we should ask is, does law of sines apply here?
Yep.
Do we have an angle in the side opposite it?
Yep.
Yep, we do. We got this 25 degrees and the 5. What can you tell me about angle A in relationship to angle C?
It's bigger than MC.
It's bigger. Okay, walking around, it looks like most people have it set up. However, solving it is becoming a problem. Has anybody got an answer, by the way? Not yet? Deb, you think so? What do you got?
49.52.
Let's see. Good. And then how did I find B so quickly? Other than, other than just clicking. But how would you find B quickly?
Subtracted from, well, add 25 and 49.5.
Yeah. Don't do law of sines again, just add up the three angles. Let's set this up and solve it because some of you look confused. Okay, so Deb, tell me what you set up.
Sine of 25 over 5 is equal to sine of -1, and then x is the angle A,
How about we call it angle A?
okay,
Okay, over
over
9. Okay, so there's the setup. No inverse yet. Cross multiply. 5 times the sine of angle A is equal to 9 times the sine of 25. And again, remember I'm putting the numbers out in front so they don't get confused in there with the sine. Divide by 5, and I get the sine of A is equal to 9 times the sine of 25 divided by 5. I don't want the sine of A, I want the measure of angle A. So how'd you get rid of the sine, Deb?
the sine of -1.
Inverse sine. Good. Take the inverse sine of one side. You have to do it to the other side. I can't fit it in there, but this puppy you plug into your calculator. Be careful with parentheses, because remember the calculator will put a pair of parentheses there. You got to close that one too. The inverse sine of the sine cancels, and we find out that A is 49.5. Well done. Could have solved for, no, you couldn't have solved for B, because you don't know how big angle B, or how big AC is. You had to solve it that way. So a couple things. Set up your law of sines, cross multiply, solve for what you're looking for, and then in this particular case, as I said, anytime you're looking for an angle, you have to do an inverse sine to get that angle by itself. Okay, questions before we move on?
How would you put it in your calculator?
Inverse sine of, okay, parentheses, 9 times the sine of 25, close parentheses, divided by 5, close parentheses. It should give you that 49.5, 4, 5, 2, 5, whatever you said. Get it? No? Ooh, may I? Are you in the right mode? Michael messing with your calculator? Inverse sine of, parentheses are already there, 9 times the sine of 25, close parentheses, gesundheit.
Is it double close parentheses there?
Yes, and you need a double, gesundheit, you need another parentheses before the 9. So you should have a double parentheses before the 9. No, that closes that, divided by 5, close parentheses. Whoops, not a plus sign, come on, read. Delete. I got it. So you gotta put you should end up with this.
Got it.
Because this set of parentheses puts the numerator in parentheses, these parentheses put the 25 in parentheses. You don't need one for the 5 because it's just 5. And then these guys put the whole thing in parentheses. Anybody else? We good? Beautiful. All right, so what happens when we don't have that relationship of an angle and the side opposite it? Notice the triangle down in the lower right-hand corner. Law of sines won't apply here. Because in order for law of sines to work, like I said, you have to have a side and the angle opposite it, or an angle and the side opposite it. When you don't have that relationship, you're going to use the law of cosines. You have two scenarios for the law of cosines. One is this one, which is called the side angle side scenario. And you're going to end up solving for the side opposite that angle. The second one is what's called the side-side-side scenario. And I've got examples for both of them. We'll get to them in a second. Okay? When I click over here and show you the law of sines, you'll see there's 3 different versions. You're not going to use all 3 versions. You're going to pick whichever one applies to your letters. In actuality, you're just going to remember one of them and then adapt it to whatever triangle you have. Okay, so there are the law of cosines. If you just memorize those 3, it's going to create a problem, because what if I give you a triangle XYZ? So notice the relationship here. Whatever side we're talking about over on the left, which is squared, it's going to match the angle opposite it on the far right. And just to make sure, keep things above board and help you out, you're going to put parentheses here. So when you copy down the formulas, put in parentheses there, because that causes some problems. So notice the first part looks like Pythagorean theorem, and then we tack on the minus 2bca. These 2 variables, the b and the c, match with the 2 variables b and c in the parentheses. The letter on the far left matches the angle on the far right. Sit down, five. Okay, we good? It's going to be fun, kids. 2 scenarios here. One is solve for the missing side. The other one is solve for the missing angle. I have both of them for you. Let's start with this one. Let's not, because I'm in the wrong mode. There we go. We'll go back to that one we talked about. Side angle, side scenario. I don't know if I solved this one or I did. Okay, there's the setup. I'm looking for A. That goes over there. Therefore, the angle that's opposite A has to be over there on the far side, 52. And then these 2 guys are where they belong. Here's the nice thing about the side angle side scenario. You can type this whole puppy into your calculator in one shot. So start here and type that whole thing in and get an answer. Go ahead. Okay? You all right? Choking on your own's good? I hate when that happens. This one is by far the easier of the 2 to solve. Not that you really sound what cockroaches sound like. Was besser? Sehr gut. Are we making progress? Yes? When you plug all that mess into your calculator, what do you get? Emmett?
30.52.
30.52. Can A be 30.52, Emmett?
No.
No. So did you screw up?
No. You have to take the square root of it.
Beautiful. You have to take the square root. Remember, that's equal to A squared. So when you type that puppy in, I simplified it a little bit. You didn't have to, because this one you can just plug and chug. You get 5.5. Does 5.5 work? Yes, it does. Because we have the 52. Well, we don't know yet. We'll check to see if it works, because we haven't done the small, medium, large theorem yet. Okay. So that tells me that A is 5.2. Now what? What if I want to find the angles? How do I go about finding the angles?
Can you use what's that called, sine or something?
Beautiful. Put a note in your notes. Wouldn't that? Anyways, put a note in there. You should only ever use law of cosines once. You can use it more than once, but it's too much of a pain in the butt. Just use it once, and then switch to law of sines. Now, why would we do that? Well, notice we solve for a. We have a being 5.5. Now we have the relationship we're looking for law of sines. We know the angle and the side opposite it, and we can go and plug and chug into law of sines. We having fun yet?
Yes.
Beautiful. Last example. Side, side, side scenario. This is the bad one. First of all, is that a triangle?
Right.
How do you know?
And the small cosine is greater than the largest.
Yeah, 12.1 plus 8.8 is greater than 19.7. Okay. Which angle are we going to solve for? Jack, what? Oh, Jack. Let me try English. Jack, which angle would you like to solve for?
D.
Any particular reason? You just like that. Okay. Andrew, how about you?
G.
Any particular reason? All right. Anybody like O? No one likes O. Screw O. I'm not doing O, man. How many want D? How many want G? How many don't care? Anybody want O?
Sorry.
Okay. Well, O's gonna need to pet the dog. Here's the problem. I'm not gonna make you do this, but if we have a camp that solves for angle D, and we have a camp that solves for angle G, there is a possibility that one of you could be wrong. Right. So, there is a certain thing called the ambiguous law of sines. We don't deal with that in here. That's a pre-calc topic that you'll get to next year or junior year, whenever you take pre-calc. So we're going to chicken out and avoid that. And the way we're going to avoid that is following this thing in red. We are always, without exception, in the law of cosines in the side-side-side scenario, always going to solve for the largest angle. That will avoid the weirdness coming up. So unfortunately, which angle are we solving for? I couldn't have played that better if I tried. We are going to solve for angle O. This calculation gets a little nasty because you plug in all the numbers and then the angle that you want is way over on the right. So we get a setup that looks like that. So go ahead and write the setup down, and then I'll take you through the steps to solve it because it's not necessarily very easy. And I'll also point out the common mistakes that people make. So make sure, aside from everything else, make sure you have written down that you only use the law of cosines once, and you always solve for the largest angle in the side-side-side scenario. Okay, you got the setup down. Here's what the most common mistake that people make when they're solving this is they take 12.1 squared, they add it to 8.8 squared, they get some number. Could somebody tell me what that number is?
Probably 19.7 squared.
Say what?
Probably 19.7.
No. Gotta square it first.
223.89.
Say again.
223.89.
223.89. They take 2 times 12.1 times 8.8, and then they subtract those two numbers. That's crucially wrong. Why? Yes, sir.
We got the cosine of O.
So,
No. Isn't that in the big parentheses, so you have to like add that to the, multiply the 2 times 12.1 times 8.8 times the cosine of O.
my Aunt Sally will be upset if you make that mistake. Please excuse my dear Aunt Sally. Also known as PEMDAS, which is the order of operations. Right. What you're actually going to do to solve this problem is you're going to take 19.7, square it, subtract 12.1 squared, subtract 8.8 squared. So you'll have a number on the left side, you'll have this stuff left on the right side, and then go from there. Okay, so I made a big jump there. Take this, take these two and subtract to the other side. Whoa, look at those parentheses. Get rid of that. Let me try that again, get rid of that, there we go. So I'm going to do 19.7 squared minus 12.1 squared minus 8.8 squared. will be equal to the opposite of, somebody tell me what 8.8 times 12.1 times 2 is. 8.8 times 12.1 times 2. 8.8 times 12.1 times 2 is 212.96 times the cosine of O. That's exactly the value?
Yeah.
Okay, beautiful. Okay, now somebody tell me what 19.7 squared minus 12.1 squared minus 8.8 squared is. Back up.
164.24.
Confirm?
Yeah.
164, give it to me again, Rebecca.
0.24.
0.24. And it's positive?
Yes.
Okay?
Wait, this is the 2 times 12.1. Where's that number coming from?
This number?
No,
This number.
yeah.
This. 19.7 squared minus 12.1 squared minus 8.8 squared.
Oh.
Okay, now what do I do? No, we've heard enough out of you today. Take a chill. Anybody else? What do I do next?
Divide by 164, or 200, negative 212.96.
Good. 164.24 divided by negative 212.96 is equal to the cosine of O. What's 164.24 divided by 212.96?
-0.77.
Negative, oh look, it's right there. Negative 0.7712. Okay, before we go any further, some of you were coming up yesterday and said, I can't get this, I'm getting an error. This doesn't work. Why? Okay, there wasn't so much whining going on, but you were confused as to why you were trying to do an inverse sine or an inverse cosine and getting an error. Whenever you take the inverse cosine or inverse sine of a number, that number has to be between -1 and 1. If it's bigger than 1 or smaller than -1, you did something wrong. This number's okay. Get rid of the cosine by taking the inverse cosine of both sides. So what's the inverse cosine of 0.7712?
140.
Megan?
140.46.
140.46 degrees. Right? Beautiful. Okay, so now we know the cosine. You see what I'm talking about. That's quite a bit more difficult to solve. I'm erasing, is that okay?
Yes.
140.5 or 46, right? Because 2 decimal places, I only went to 1. That's beautiful. Now I know that angle O is 140.5. What do I do next?
Law of sines.
Law of sines. For which angle? D or G? Well, there's 3 answers I heard. D, G, or any. 4 is none. That's not an option, so get rid of that. So we're back down to 3. Any? Who said any? Why?
Because you know all the sides.
Yeah, so we have the relationship of the angle and the side opposite is, so you can use any angle. Who said D? Liars! Scary too. G? Why, Grace?
Because it's the second largest angle.
Bingo. The correct answer is G. Not only are we going to solve for the largest first, we're also going to transition then to the next largest angle. Why are you waving your hands in the air like you just don't care? So go ahead and find the angle, which one's the next biggest one? G. Go find angle G. Using not the law of cosines, not right triangle trig, but the law of sines. And hold on before you start the calculation. This is the point where things break down. We have to use calculated information here. You have to use that 140.46 that you stored in your calculator. There's no way around it. Once you get done, look up, the answer's on the board. For both G and D. Found G using law of sines, subtracted from 180 to find D. Do a quick small, medium, large check, and I am good to go. Pregunta.
Why did you use 19.7 again? That was
Because that's, law of sine says you have to take the angle
great.
and the side opposite. So 19.7 is opposite of the angle of 140.5.
Okay.
I'm looking for angle G, and the side opposite angle G is 12.1.
Oh, got it.
Common mistake that people make with law of sines is I set it up as the sine of 140.5 over 19.7 equals G over 12.1. Don't do that. Sine of G. Okay? Problems? Questions? Concerns? This isn't necessarily easy. The problem that people run into is not the geometry, they screw up on solving the algebra problem. Don't do that. Okay? There's some checks and balances in place. When you get done, look and see if your answer makes sense. If you get an answer that says error, you probably did your calculations wrong. If you get an answer where the angles don't add up to 180, you probably made a mistake somewhere. Go back and check your math. Specifically in the side-side-side scenario for the law of cosines, that's where most people make the mistake. They either use the first angle, or they choose the wrong angle to do first, or they just screw up on their calculations by doing that minus that I already pointed out. Emmett,
I have 12.1 sine 140 equals sine G. What do you do after that?
say that again.
12.1.
You cross multiply.
Yeah.
Okay.
And then you have to multiply it by the inverse sine. What do you do after that?
So you have 19.7 times the sine of G is equal to 12.1 times the sine of 140.5, correct?
Yeah.
Okay, divide both sides by 19.7. So that gives me the sine of G is equal to 12.1 times the sine of 140.5 over 19.7. How do I get G by itself?
Inverse.
Yeah, I do.
Inverse sine of this side, which means I need the inverse sine of this side. This is the one that I was helping Vanessa with. That's the ugly calculation that you got to figure out all the parentheses using your calculator. That side will just end up as G. Question?
Wouldn't it be better if you just like made the top part into a number like 12.1 sine of 140? Like if you multiply it, you get a number, and you can just divide that by 19.7.
The problem is I can't grade your calculator. So yeah, if you were an engineer where you just had to build a bridge and your boss didn't care how you did as long as people didn't die, I would wholeheartedly encourage that. But I have to be able to grade it. I don't want to just grade it right or wrong because then that would be bad. All right, we good? It's gonna be a little scary, kids, but the benefits far outweigh the negatives. That we can now work with any triangle that we want, regardless of that. So this tournament's coming up, so I found some funny basketball pictures. All right, questions? Let me unlock day. What are we on? Day 9. Day 9.
Why?